things that are there in the system. So if the biometric image is compromised, then we pretty much we can't do much without the secrets. So even if I can capture somebody's image and fool the system that I have a particular face, without the secrets, I cannot use the model to generate the biometric key. So I can't get to the key. But even if the model is there and the image is there, I cannot map a particular biometric to a point to say, okay, which class does this particular image belong to without the hashing secret. Another interesting aspect is what happens if all of this is compromised. If all of this is compromised, we still show that the process is one way. From the biometric key, you cannot go back to the original image, which is a very nice thing. Another thing is that if everything in your device is compromised, so you can consider the case where you store all your secrets in your laptop and the laptop is compromised. Then we show that without the biometric, you can't use all the secrets and all the information stored in the machine to actually regenerate the secret. So this is one of the main requirements. What's the point of having a biometric if everything is based on stored secrets? So this is one of those main cases. Okay. So at this point, I will go into the last aspect, which is to do with the history-based identifiers. So we looked at the main zero-knowledge proof protocols, which do the multi-factor verification. Then we saw how we have to play with the biometrics to make them fit well and use with the rest of the identifiers. So one good thing over there is that I'm not using the biometric or multiple biometrics together with each other, but also using them with other identifiers like social security number and so on to do this multi-factor proof. So it becomes a very flexible, scalable system. So now we also consider what happens if we are considering what you do. And the main idea here is to use the e-commerce and m-commerce activities. Does everybody know what is m-commerce? Nobody? Mail commerce? No, close. M is for mobile. So nowadays, people have really fancy phones and stuff, and you can do a lot with those. And the idea is that when you are using these mobile devices, you can use them just as an extension to e-commerce activities. So we were thinking that history should really be incorporating all sorts of activities. Some that you do online, you're buying things online, but also maybe activities that maybe in future we go to a Walmart and are able to pay with this or get receipts on this and so on. So the challenges, the security challenges here is to be able to leverage these past transactions, either online or in person, as I just mentioned, to be able to establish trust with all this information. So you could use it for rebates, e-prescription, but then we also want some security and privacy properties to hold. In that, we want to make sure that the person who's claiming these attributes, history-based attributes, is the owner of these. So I don't steal all the information, the nice information that you have, and present myself as the person who did all this. Another thing is that this information should be in control, especially in cases of mobile devices. It's maybe easier to capture this information and somebody can potentially misuse it. So we want to make sure of that. Another thing is the availability. I don't think many of us can really prove to some shop that I really came here last semester and I bought books more than $300. Those are the things that is not easy to prove at this particular point of time. So the key idea over here is that we take this transaction history and encode it as electronic receipts. And the idea is to enroll these receipts at the registrar and have something called the receipt record, which is similar to the identity record that we had for credit card numbers and so on. So based on a very few simple protocols, by this time I thought everybody will be zoned out, but the idea is to understand how we could potentially add these receipts and how could we use them for certain kinds of transactions. So Homer again goes to eFollets, a website, and buys a book, and he says, okay, I want a receipt for this book. Then the service provider starts a session handle, which is denoted as the random. The next step is that Homer goes to the registrar. The registrar is the entity which is basically using, managing this information. So he says, this particular receipt record is mine. So he points out on that, and he claims ownership on a receipt record through multi-factor verification. Okay? So once he has strongly verified his identity to the registrar, he starts creating this row submit, which is another token with some session handle to say, okay, you can submit a particular receipt. So Homer goes, he takes this particular row submit, gives it to the service provider, and now the service provider creates a receipt of a certain form, creating based on the particular transaction, who's the seller, who's the buyer, so on. And he gives this receipt, which is passed on to the registrar. The registrar can simply add this. So, since there's a time, I can ask a question. Do you know what was the main reason why TJX got in trouble? Like the TJX case was the point where it was storing a lot of users' information, the driver's license number and whatnot. So they were storing all this information for a particular reason. Do you know that? It was basically storing these information so that if a person comes later and says that I don't have the receipt but I want to return this item, so the shop wants to make sure that it is the guy who actually bought the item. So when the person buys the item, it records the driver's license number and so on. So at the time of return, it can check if it's the same person. So this is too much information to store just because of this particular thing. So there are lots of solutions, very simple solutions that can replace the need to store all this information. Because what happened was that this information was compromised and now it's liable for a huge amount of money. I really don't remember exactly the amount, but it's reasonable if you check the news. But over here I show one particular case of how a system could be used to return an item. So here you don't provide any more information than the receipt which is recorded on that, or even if the receipt is not there, you can prove ownership on a particular transaction. So to do that, first what Homer does here is that he goes to the registrar, he verifies his identity using this multi-factor verification, strong verification techniques. And then he identifies this particular receipt. And the registrar gets ready. He says, okay, I'm going to revoke this eventually once you return the item and all that. So now what Homer does is when he's trying to revoke a particular item, he also proves ownership. Like if you see in step 2, a part of the identity record is given to Homer. This is signed by the registrar. So I have not provided too many details, but the idea is based on this identity record, what Homer can do at step 3 is to prove ownership on that receipt and saying that I am the guy who has bought this item earlier. And he does this in zero knowledge fashion, so not more information is revealed than what has been recorded. Then they want to make sure that there is fairness in this whole transaction. That means that if Homer goes and returns the item, we don't really trust the service provider, so we don't want the service provider to run with the item and not provide the refund. So we want the return, the refund, and the revocation of the receipt all happen simultaneously. And that's why we use a simultaneous contract signing. As a next step, when, as per the contract, when Homer goes and returns the item, basically the service provider provides a refund token, which really provides F, which is a refund, and a revocation token, which says that this particular receipt needs to be revoked. It's encrypted with registrar's key, so at step 7, the registrar gets it, and it revokes it and gets the refund back to Homer. Okay, so we had those protocols at an online version, and more recently what we did was, okay, now what happens if you're just having these little devices, our cellular phones with us, and we had to do something like this in an actual physical location. So one would think that the challenging part is, okay, how much can I store, how many receipts can I store, and also most people think that zero knowledge proofs take a long time, and it's potentially, so most of the phones nowadays are good enough, and I'll show you some figures that we can do multi-factor proofs using such devices. So as you can see in this example, Homer goes and does this online e-commerce transaction, and as per the earlier protocol, it can add a receipt. And a step that I didn't talk about was that you can take these receipt attributes and you can extend them. And basically what you can do is to create some cryptographic commitments of these receipt attributes. And basically the idea is that once you do the cryptographic commitments, then you can prove that you have a receipt attribute without showing it in clear. So if you want to do that, then you extend a particular receipt attribute. So Homer goes, he uploads the receipts, and he